Our second review video deals with factoring quadratic polynomials. And we're going to start with quadratic polynomial. A quadratic polynomial is something in the form ax squared plus bx plus c. And generally in our math, those are going to be set equal to 0. Now, today we're just going to look at primarily what happens when a equals 1. When this number equals 1. Because that's the easiest case. Actually, we may proceed on to when a doesn't equal 1 too, because I want to cover enough today, and then in the third video, review a little bit and add the quadratic formula. So we actually we'll start with a equals 1. How about that? So, how do we solve these problems? In order to solve a formula that's like, say, x squared plus 8x plus 12 equals 0. Let's say that's my polynomial, okay? I can't just solve that by saying subtract 12 from each side and x squared plus 8x equals negative 12 and then having to, because I got an x squared and an x, it doesn't work. Our normal techniques of solving linear equations do not work when I have a quadratic polynomial. If I have only an x squared term, I'm fine. If I have, say, x squared plus, or not plus, that would be bad, x squared minus 9 equals 0, I can just do x squared equals 9 and take the square root of both sides. That's called solving by extraction, and that's perfectly fine. X equals positive or negative 3. We have to remember negative 3 squared also equals 9, not just positive 3 squared. So we get both solutions. But there's no middle term here. There's no bx term there. And that technique is pretty simple. That's straightforward. I'm not worried about that. I am worried about this, solving something like this. We have to factor the polynomial, which is FOIL backwards. Now, one thing I noticed when I do simple FOIL, let's say I have x plus 2 times x plus 5. Let's just FOIL that out, for example. X times x gives me an x squared. X times positive 5 gives me the plus 5x. X times 2 gives me a plus 2x. And 2 times 5 gives me a plus 10. Or x squared plus 7x plus 10 is my solution. But I want you to notice something really neat. The 2 plus 5, the positive 2 and the positive 5, when I add them together, that equals 7, which is my middle term. The 2 times 5, again, using those two numbers, equals 10. So the terms of my polynomial after FOILing are actually directly related to my original factors of that polynomial. And we're going to use that information to help us deconstruct these, to factor these already put together quadratic polynomials. So what I'm looking for here are what we will usually refer to as magic numbers. I'm looking for two numbers that are going to add up to give me my middle term here, which is positive 8. And multiply, sorry, that should be a times, to give me a positive 12. What two numbers add up, and this is where we got a little thought problem here. What two numbers add to give me positive 8 and multiply to give me positive 12? Well, I start by thinking what numbers multiply to give me the 12. 1 and 12. 1 and 12 don't add to give me 8. 2 and 6. Aha, there we go. 2 and 6 are my magic numbers. And when the leading coefficient out here is 1, if there's not a number in front of the x squared, my factoring problem is super simple because I get x plus 2 because a positive 2 and a positive 6. X plus 6 are my factors of that polynomial. Now, we've factored it. We haven't solved yet. The question I have here is I'm still multiplying. Now I'm multiplying two terms and getting a product of 0. And this is an extension of what we call the zero product property. Okay? The zero product property says if a times b equals 0, then a has to equal 0 or b has to equal 0 in order to get a zero product. So if x plus 2 times x plus 6 equals 0, that means either this equals 0 or this equals 0. So what number would I put into x plus 2 to make that a 0? Well, if I put a negative 2 in there, if x equals negative 2, then I get 0 times 4, which is going to be 0. So x could equal negative 2. Or, well, if I put a number in here to make the x plus 6 equal to 0, negative 6 would do that. So x equals negative 6. And we have our solutions. So our factors lead us to our solutions. The factors and the solutions are different things. They're often referred to as factors and roots. Let's do another one. Okay, so I'm looking for my magic numbers. Blank plus blank has to equal negative 9, positive 9, excuse me. The sum is the middle number. And blank times blank has to equal negative 10. So what two numbers multiply to give me negative 10 and add to give me negative 9? Well, a little hint. Since we're multiplying and getting a negative, they have to have opposite signs. And since the sum is positive, the bigger one has to have a positive sign. So I got 10 and negative 1 here as my magic numbers. So this is going to factor into x minus 10, x minus negative 1, or x plus 1. What? Wait a minute. No. That was a mistake. Sorry, I get ahead of myself sometimes. It's x plus 10, x minus 1. Okay? And my solutions wind up being negative 10 and 1. Because negative 10 would make this term a 0, 1 would make this term a 0. Sorry, got ahead of myself there on that one. Let's do one more. In fact, I think we are going to limit ourselves today to just this type of factoring. And I'll get into make another video for when the leading coefficient isn't 1. So x squared minus 6x minus 16 equals 0. So my magic numbers again, blank plus blank has to equal negative 6, blank times blank has to equal negative 16. They're both negative. The product is negative, which means my numbers have to have opposite signs. Negative 16 could come from negative 16 times 1. That's not going to work. It could come from negative 8 times 2. Aha, there we go. Okay, so this is going to factor into x minus 8, x plus 2 equals 0. And the solutions wind up being x equals, well, positive 8 would make this one a 0, and negative 2 would make that one a 0. All right, maybe time for one more. Okay, so I need two numbers multiplied or added that equal 10 and multiplied that equal 25. What two numbers add to give me 10 and multiply to give me positive 25? They're both positives. That's great. Okay, so that would be 5 and 5. So this is x plus 5 times x plus 5 equals 0. So my solutions are x equals negative 5 or x equals negative 5, which is the same solution twice. So really we're only getting, it's called a double solution, but we only get one numerical solution for that. All right, that's it for this one, and we'll pick up tomorrow with leading coefficients other than 1.